Great, thank you. Yeah, because I was thinking that with everybody's permission, this might be a good seminar for the R consortium channel. Since this is how we found out about it.
That's true. That's true. Just for your information, we will have a similar, not exactly the same slide deck, and different presenters from the working group presenting to the R adoption series next week, which is also hosted by the R consortium. So we can then maybe you can check with them what they want to show where and so on. Just that it's not like not the exact almost the same thing like posted there, but just for your information. Yeah.
That sounds really great. So maybe Daniel, you and I could communicate about that and make sure we're
Right.
on the right page and doing the right thing. So
yeah.
So great, thank you. And one of these months, I'm going to get a slide together, like an intro slide that talks a little bit about our govies and our connection with the data community DC. I always get that wrong. And the American Statistical Association, the R consortium, and so on. But in essence, our govies kind of grew out of the interagency R users group, which is I don't know, it's a grassroots group that has no official standing, but we have a lot of fun together and we share a lot of good things. And that group, we wanted to have, I guess, sort of a little bit of an official arm, so to speak. So we started talking to the our consortium, so Joe Reichert, and he helped us a lot get this going. So we're our govies is now kind of co-sponsored by the R consortium, the American Statistical Association, as I said, Data Community DC. We'd love to have other sponsors. So, if you have groups out there that would like to join with us, that would be fantastic. And it's called R govies, but there's nothing, I guess maybe some could argue with that about this, but I don't think there's anything particularly special or unique about the needs in government agencies around the world for statistics. So regression is the same no matter where it's done. So you don't have to be a government person or doing government work or whatever to join with us. We have topics of general interest that we'll hear today. So I'm going to let Daniel and Yaa introduce themselves because they know themselves better than I do. So I'm going to pass the platform to them, and I guess Donna, they can share, right?
Absolutely.
Okay, perfect. So Daniel, I'll let you take it away.
Okay, I'm gonna share my screen, and actually Yaa is gonna start the presentation. Maybe just a quick intro first from my side. So I'm Daniel Sabanés Bové, statistician by training and working for Roche in Switzerland. And as mentioned before, that's also joined with Genentech in the US. That's the same organization. And today we are not gonna talk too much about Roche stuff. It's really about open source, and I'm really excited about that. And with that, I would like to pass over to Yaa, and then she can introduce herself as well and take it away.
Yeah, thanks, Daniel. My name is Yaa Wang, and I work for Gilead Sciences, actually based in Foster City, California. And I work in a group called the Biostatistic Innovation Group. It's basically kind of like the group doing some statistical initiatives, the methodology and consultation, and also software development. So happy to be here today to introduce our working group. I think we can get started. Okay, so here is the outline of our presentation for today. So I will start with the introduction to our working group, and then Daniel will talk about our package mmrm that we have developed, and then I will conclude with some closing remarks and our next steps. Yeah, next slide, please. Okay, so what is the SWE working group? The ASA BIOP software engineering working group, SWE for short, is an official working group of the ASA Biopharmaceutical Section. It was formed in August last year and has been expanded rapidly. Currently, we have more than 30 members from over 20 organizations. Majority are biopharmaceutical companies. We view this as a great opportunity to work collaboratively across industry to tackle unmet needs in the statistical software development. We have launched our website through the R Consortium GitHub organization, where you can know more about our working group, the projects we are currently working on, and some public training materials on software development. Yeah, just check it out when you have a chance. And we are also open for new members, so feel free to reach out if you are interested. Now let's talk about our motivation on forming this working group. I think we all agree that reliable software for statistical analysis is essential, especially in clinical research, as the software supports the clinical decision for patients. In the past, a lot of statistical analysis have been performed with proprietary software, such as SAS and Stata. However, over the last 2 decades, open source software, such as R, has gained increasing popularity in biostatistics. It enables the rapid uptake of novel methods and offers great opportunities for collaboration and innovation. Of course, it has drawbacks, which are the huge variability in the software quality, in particular, the reliability, the efficiency, and the maintainability. Next slide, let's use R package development as an example. The current repositories, such as GitHub and CRAN, they do not require any statistical quality assurance. And a package becomes even more difficult to use without good documentation and maintenance. Therefore, developing high quality software with good coding practices, the reproducible outputs, and the self-sufficient documentation is critical to inform clinical and regulatory decisions. So we think there is an opportunity for us to improve the way open source software is developed, which motivates the formation of our working group. So in this slide, I will introduce our goals. And the primary goal of our working group is to develop high quality R packages that implement important statistical methods to fill gaps in the open source statistical software. And we work collaboratively across the industry. Our secondary goal is to develop and disseminate best practices for software engineering. We will do it through public training materials, the video clips, and some workshops. Yeah. So next slides, I will introduce some our working group activities. Our first R package, mmrm, was published on CRAN in October last year, and it got updated in December. We aim to establish this package as a new standard for fitting mixed models for repeated measures, which Daniel will introduce this package in a second. In addition, we have been developing and adopting best practices for software engineering in this particular package, and we open sourced it at our GitHub page. Currently, it is under active development to add more features. We are also preparing for public training materials to disseminate the best practices for software engineering in the biostatistics community. In early February, we will host a face-to-face workshop in Basel, Switzerland, with a focus on open source software for clinical trials. We're also organizing conference sessions at CN, JSM, and ASA FDA workshop with a focus on statistical software engineering. Recently, we started a YouTube series on the ASA Biopharma YouTube channel to introduce the best practices for software engineering. All relevant materials and the links are available in our website as well. Yeah, so just check it out. And here I just mentioned a few best practices for software engineering, which includes the user interface design that makes sure the interface elements are easy to access, easy to understand and use. The second one is the version control, where we can track and provide control over the changes to the source code. Next is thorough unit and integration tests that will make sure the individual unit of the source code, as well as they put together as a whole, behave as what we designed and are fit for use. The next one is the consistent and the readable code style. And this will make sure that everyone, or at least the whole development team, can understand the code we are written. Next is a good documentation, which help explain how to use our code to other people, or it can also be a very good reminder to ourselves in the future. Another one is called the continuous integration setup, which automates the building and the testing of our software on every new commit. So here the fundamental tenet is to commit and integrate your code very often so that you can identify and resolve any merge conflicts earlier, or you can just avoid them. Next one is the publication on website and the repositories to make it open source to everyone, and much more. Yeah. So next, I will pass it over to Daniel, who will walk you through the mmrm package that we just recently developed.
Great, thanks, Ya. So I'm gonna dive more into the mmrm package. So what was the motivation for building this package in the first place? Let me say a little bit about this mmrm because it's a little bit a pharma-specific term. So that's basically called mixed models for repeated measures. It is a very popular choice for analyzing longitudinal continuous outcomes in randomized clinical trials. It basically, there was no great R package so far that basically fitted this kind of models. It is a bit similar to what LME4 package, for example, covers. LMER test package adds then certain additional features on degrees of freedom adjustment and corresponding test p-values and so on. But we thought it was solved by that, but then we actually found out when we give it a larger trial data set with more time points and more patients that this approach actually failed, unfortunately. So it was very, very slow and it didn't converge in most cases. So that was our kind of first experiences to try to implement this this class of models in R and our first kind of solution attempt. We also looked at an LME package, which also allows the fitting of linear mixed effects models. Unfortunately, here we are missing a certain degrees of freedom adjustment, which is called Satterthwaite degrees of freedom adjustment. And we also had convergence issues still. Also the least square means, so basically the average response at each time point that can be estimated from the model. We can use the so-called EM means package to get an approximation, but it's really only approximate. So we didn't get the same results, for example, as with proprietary SAS software. So that was the kind of starting point why we needed to look at other solutions. Of course, before creating a new package, one should always be careful to go this route because there's already almost 20,000 packages on CRAN, and the question is always like, do we really need a new package? So it's always better to first try to improve existing packages or contribute to them, or yeah, maybe you just use them in the first place. So here actually we tried to do that. So we looked at the so-called GLIM TMB package, which is even more general, so it can fit also generalized linear mixed models. That's where the GLMM part of the name comes from. We tried to extend this package to basically give us this adjusted degrees of freedom that we need. But unfortunately it didn't work. So we tried a couple of weeks also together with the authors of GLIM TMB, but in the end it didn't work. So the results were not correct. And this was probably because there was some tricks being used in the GLIM TMB package to fit the kind of model that we wanted, and not exactly basically on a clean slate, really fitting the model that we wanted. It was an approximation again. And of course, we also then need to think about long-term maintenance and responsibility, because once you publish the package, it typically will be there much longer than you think initially. And maybe if you are not interested anymore after 1 year, other people might still be very interested in it. Maybe they have built their scripts on your package. So it's very important to think about that as well. And I think that's also where the software engineering working group idea came to being, that it would be much better if we not just from one company or organization develop this, but really like across organizations. Okay, a quick overview of the package, what it's doing. So what is this mmrm? It's really just a linear model with where you have dependent observations within independent subjects. So typically you have the subjects in our domain are the patients, but it could also be other units that are independent of each other. And within those kind of units or subjects, you have dependent observations. And you basically want to explicitly model this dependency over time within subjects. Okay, that's basically the main idea. So in the end, it's just a general least squares model, right? And where you also estimate basically the covariance of these dependent observations within the subjects. And for this covariance, we have, of course, you can assume many different models for this covariance structures. And we allow multiple covariance structures. We will see more details later on this. For the inference, also, you have two popular choices. You have the maximum likelihood estimation, where you basically fit both the covariance and the coefficient parameters at the same time. So you maximize the likelihood over both simultaneously. Or the restricted maximum likelihood, which is basically first integrating out the coefficients of your linear model from the likelihood. Then you have an integrated likelihood, which only depends on the covariance parameters. And then you maximize this restricted likelihood. So that's the so-called REML estimation. So we support this, the package supports both. And also, in addition, we have prepared the ability to use multiple optimizers if needed. So that means, of course, it's a numerical optimization. So there's no closed form solution for this maximum likelihood estimator or REML estimator. So we have to use, kind of Newton-Raphson approaches. Depending on which approach you take there, which optimizer you use, it might not converge in the first place. So we have basically provisioned that if the first optimizer fails, then you could still automatically try a few other optimizers and see maybe if one of them works and gives you convergence. So that again increases the chance of convergence. We have interfaces to other important packages in this space. So as mentioned before, we have an EM-means interface for calculating the least square means at the time points. And we also now, just recently in the development version, added the tidy models interface for easy model fitting and also comparison with other package results. We also now have already on CRAN version, we have not just the Satterthwaite degrees of freedom adjustment, but also the Campbell-Roger degrees of freedom and also covariance matrix as adjustment. So that Campbell-Roger is a little bit more complicated in the sense that you also adjust the covariance estimation for your coefficients. So that's also included. And that's, at least in the pharma space, that's a very important thing to have. Okay, why it's not just another package? So why it's not just one of those 20,000 packages? Maybe hopefully it's a little bit better than just any random package that you could pick from CRAN. So we really want to ensure ongoing maintenance and also support and development from the industry via the software engineering working group. So currently we already have 5 companies being involved in the development, and it's on track to become a standard package within this model space, basically. And we really try to use the best practices here, as mentioned before by Jan already, as a kind of a showcase for how to build a high quality package and how a high quality package looks like. And there's actually a lot of details that are in there, and that's we will also try over time with this YouTube series and workshops, etc., and maybe even writing some white papers or something. So we will try over time also to infuse this knowledge into the general community, and hope to increase the awareness of these best practices. In particular, one thing just to note again, as mentioned also by Jan before, unit and integration tests are really important, and still many packages don't have them. So that really makes sure that your software works as intended and keeps working as intended. And we also here, in particular, compared results with SAS very diligently during the development, and encoded and basically fixed those tests, basically those comparisons in the tests, so that we ensure that if you run the tests in the package on any platform the package is installed and those tests pass, then you can be very much trusting that the package really works as intended on your installation and on your system. A few here comparisons with SAS, because it's so relevant, at least in the pharmaceutical industry still. Just on the covariance structure choices. So we basically see here the list of the 9 different covariance structure. Sorry, not 9. So we've basically 11 in total. So if you also count the unstructured here. So we have unstructured, and that can be weighted or unweighted. So actually the weights you can also apply to any of the others. In addition, we also have triplets, so you have the heterogeneous variances across the time points or the homogeneous variances. So basically the same variance across time points. Compound symmetry, again, both versions, or the regressive first order, both versions, antidependence, also both versions, and then spatial exponential. So we currently only have one of this kind of so-called spatial covariance structures included. But we could relatively easily add more. For example, if you have a use case where you need another spatial covariance structure, please let us know on GitHub or via email, and then we can relatively easily add that to the package. And we see that both, basically both softwares kind of match here. Only the antidependence, there's a small difference here between PropMix and mmrm. And of course, it's fair to say that PropMix has a lot more covariance structures in addition to these 11, let's say, implemented. We just don't show them here. So PropMix has even more that we don't have. But these are kind of the standard ones that everybody's using in the pharma space, at least. And again, this could be relatively easily extended. If you need another one, just let us know, and we can relatively easily add it to the package. Okay, degrees of freedom methods. I mentioned already that we have Satterthwaite and Kenwood-Roger. There's also a small variation of Kenwood-Roger, which is called Kenwood-Roger linear. So it's just a little simplification for the covariance matrix adjustment. That's also included. There's also a second version of Kenwood-Roger called KR2 in SAS. We don't have that so far. That's even more complicated to calculate, and typically Kenwood-Roger is sufficient. There's also a very, very simple degrees of freedom methods, which are basically not really adjusted, but very, very simple, definitions for degrees of freedoms, which basically take into account the number of observations, the number of subjects, and the number of time points. And those we currently don't have yet in the package itself, but at least for least square means, you can get them through the means package, and we're currently also looking at adding them to the package itself. Okay, a little bit more about the least square means. And also about contrast. So basically, either one-dimensional contrast, so linear hypothesis testing, or multi-dimensional, multivariate hypothesis testing about the coefficients. that's implemented in the package itself already with this df1d and dfmd functions. And there's also S3 methods. So basically the interface to EM-means available. If you want to look at differences of least square means, that's also possible through EM-means. So that's all going via this interface. And in particular, degrees of freedom method is basically passed on from mmrm to EM-means. So we will see that later a little bit more in the example. It's a little bit maybe abstract like this, but we will see that in the demo. Okay, and there's some detail around adjusting for multiplicity. So in both our package and SAS don't do that by default, and EM-means is doing it by default. So something to be aware of. Oh yeah, and there we're already at the demo. So I'm gonna exit here the presentation mode. So basically, what I would recommend you, if you're interested, have a look at our at the website of the package. So that's openpharma.github.io/mmrm. And probably if you search on Google mmrm package, probably you can also find it relatively easily. See the URL. So you already have the cron link here. And if you go on the cron link, you also can relatively easily click here on the website, on the URL. Okay, and this is where we are. So you get a starting page, which is basically the README page, which is just a very high level description of what the package is doing, what are the features and how you can install it. And we basically want to look at the introduction vignette, which is also linked here, the introductory vignette. Okay, and let me make it a little bit bigger. Okay, and by the way, if I'm going too long, please let me know anytime. So and let's also look at R quickly. So basically, I installed the package, and then we can just load the package as usual with library mmrm. You can also look at the vignette, of course, in RStudio, for example. It's maybe not as nice as on the website because you cannot easily copy paste the code examples. You have to really mark them, select them, and then copy paste. But on the website, you can actually just click on this icon here, and then it's copied to the clipboard already. So that's a little bit more convenience. So what's going on here? So basically, this is saying we want to fit an mmrm. So this kind of specific general linear model where we have a response variable FEV1 here in this case. We have certain covariates. And here comes now the specification of the covariance model. And we basically have to say what's our unit ID variable. So this is here a subject ID variable, and what's our time point variable. Okay. And when we look at the kind of data set which is included in this package, which is called FEV data, then we see, maybe let's just look at the head of it. Then we see how it looks like, and also when we look at the summary quickly, I just want to show one important thing. And so we said a visit here is our time point variable. So this is actually a factor variable. So this is a categorical variable that has 4 levels, right? Visit 1, visit 2, visit 3, visit 4. And here it's balanced. We have 200 for each visit, right? So what I want to say is for all the non-spatial covariance structures, we have to use factors, so categorical time point variables. And why is that? Because basically those non-spatial covariance structures basically don't know anything. They don't appreciate any kind of time differences between the time points, but they only say, this is the first one, this is the second one, this is the third one, right? Whereas if you can also go to spatial covariance structures, then you can really use continuous time variables. That because that kind of spatial covariance structures, they really look at the differences of the time points and then model the covariance based on these differences and the parameters, right? So there's a big difference there. And this US, that's basically a specification of the unstructured covariance model. And we can look at this if we look at covariance types. So that's giving a little overview of what kind of covariance structures are available, and we see here unstructured is here, for example. Right. We also have here the spatial exponential, for example. Okay, so you see there's different models, and they have also different number of parameters. Basically, the unstructured model is basically the most general for this non-spatial structures, in the sense that you basically just want to fill this matrix, this covariance matrix that is still positive definite, and otherwise you don't have any restrictions, right? Okay, so that's kind of what's going on here. So we and we can fit this model, and there it's already done, and we can look at it, and we can just print it. And then what we see here is a little summary. So not really summary, like a little description. So we see what was the formula, we see what's the data set, we see how many observations were there used. So this is basically after discarding any kind of missing data points. So basically any kind of rows or any kind of time points where we have any kind of missing information on any of this kind of covariates, right? And we have maximum 4 time points. Okay, and then we have the covariance model here. It has, because it's 4 by 4 matrix, we basically have 10 variance parameters for there. And here by default, we use the REML estimation, so the restricted maximum likelihood inference. And we have a deviance statistic as well here. And we see the estimated coefficients. And also we get some information here on the optimization, how it converged and what was the convergence message, right? So here everything looks good. And then of course, like in usual in R, you can also say summary. Then you get more information. So when you say summary on this model object, we get this kind of header again. Now we get a few more model selection criteria. So we also get an AIC, we get a BIC, we get the integrated log likelihoods. We get the coefficients table, not just with the estimates, also now with the standard errors, the degrees of freedom. So by default, these are Satterthwaite degrees of freedom, and the t-statistics and the p-values, right? And we also get the covariance estimate, right? Because again, this is also something we estimate from our data with these modeling assumptions. And here you see this is a completely unstructured matrix, right? There's no structure imposed on this one. Okay, what else did I want to show? Let's look again at the vignettes quickly to get some inspiration. By the way, if you have any question what I should show, let me know. Yeah, I mean some kind of stuff goes via this control argument.
Daniel?
We can. Yes, maybe we have a question. Yes.
Since you offered to let me interrupt, can you try another covariance structure so that
yes,
you could see?
Very happy.
Okay, great, thanks. Just to see the difference. Exactly.
So basically we can have another fit2, and then we can, for example, here say, let's have, I don't know, interdependence. Maybe interdependence. Yeah, but let's have the very simple interdependence. And I just have to change this little covariance specification here, right? And everything else can stay the same. Okay, this was even a bit faster, and we have fit2. And we see now here, we only have 4 variance parameters here. And when we look at the summary, we can look at that. So, and of course, if we now want, we can also somehow compare them. I think we don't have an ANOVA method. It's also a bit difficult because you want to compare different kind of covariance structures. It's not so straightforward, but we can, for example, also do BIC, right? We can look at BIC of fit. We can look at BIC of fit2. And we see actually here the unstructured model seems to be better. And we can also directly look at the covariance estimate. So when we do this varchar, we get this kind of matrix, and we can also look here. So here, for example, we see that those estimates are quite different, right? Because we really have a lot of structure imposed here on on the second fit.
That looks
Okay.
interesting. Thank you.
Okay. And that's actually a reason why from pharmaceutical industry, of course, has a lot of stakeholders in FDA and EMA regulatory agencies, and of course from regulatory side, they always want to have the unstructured one because that has less restrictions on the model, right? Okay, it's also possible to use maximum likelihood estimation. You just say RAML equal false. That gives a little bit of difference as well. Of course, typically we use the restricted maximum likelihood. You can also directly change the optimizer that is used if you want. Typically, I would not recommend that because you have a pretty robust behavior with the default there. Yeah, covariance structure, we looked at that already. It's also nice to have the ability to have weights, right? So maybe you have some surveys, or maybe you have some different kind of precision on outcomes. So it's also possible to support weights. And let me just show you how this works. So maybe let's put this here. So we can also have weights. Oops. And this is supplied like a vector, right? So this is like in other kind of R functions. It's not in a formula interface, but it's just basically the vector. And we have already here some weights in our example data sets. And you then also see this here when you look at the object, you see that you have the weights here, right? So those are kind of subject and time point specific weights that can be included in the estimation. Yeah. Oh yeah, there's also another variation to have grouped covariance structures. So sometimes you want to have this. I mean, you always have the same covariance model, but maybe you want to have different parameters by certain group, right? So that's also possible with this kind of nested kind of syntax here. You can basically have the subject within groups here. So that also works. Yeah, with the method, you can choose Kenwood-Roger, for example. So maybe we can try that out quickly, just to show how that differs. Fit 4. And for example, now if I look at summary of Fit 4, I see here also the method Kenwood-Roger, right? And then I have, in this case, the degrees of freedom will still be the same, but because it's univariate kind of tests here, but you will see that, so for example, right? So here I have, for example, I don't know, intercept, I have here 0.8978 with a satisfied, so with the unadjusted standard errors. And if I look here at Kenwood-Roger, it's slightly different, right? Whereas the degrees of freedom is exactly the same because it's a univariate test. For the multivariate contrast test, it's different. There we have also different results for degrees of freedom for Kenwood-Roger. Yeah, so that's kind of what's going on. There's some detail if you wanna maybe there's some time points completely unobserved, but you still want to model them with a more restrictive covariance model. Of course, it doesn't work if you have unstructured, but if you have like AL1, for example, you could do that. So that's also possible. Summary, we already looked at the summary. Of course, when you have the summary, or you can also extract things further from that, right? Oops. So just to say, for example, I mean, I can also say here, this is my summary or sum 3 or something. And then I look at sum 3 to understand what's in there. And then, for example, I can also look at this coefficients table. That's also kind of standard, like in other. So now I just have this kind of matrix, right? And can maybe put this into a table or something, right? So this works like in other our packages. So we try to stay very close to the general look and feel of other modeling functions, right? There's another thing, if you want to look at some details, we have this component function that's basically extracting certain information from the model. That's maybe more for detail later, and also some lower level functions. I talked about the hypothesis testing a little bit already. I think EME is also maybe interesting. So basically, what we can now load the EMEans package, which is separate, right? So we try to not reinvent the wheel. And now we can look at, for example, by visit and by treatment arm, by treatment group, we can look at these least square means, right? So here, that's what we get, right? So this is kind of can be interpreted like as the average outcome that is estimated by the model at visit 1 and for example in placebo group or in treatment group, with the corresponding standard errors, degrees of freedoms, etc. Okay, so that was kind of my demo. Any questions on the demo before I pass back to Jan, maybe? No? Okay.
Yeah,
No
hi.
problem. Oh, yeah. Yes.
Hi, Daniel. This is Scott Cheslow here.
Hello.
Thanks for a very nice presentation. Just a quick question. It looks like the return object from mmrm is just a list that you've given an S3 class. Is that correct?
That's correct. Yeah, we use S3 in this package. Yeah.
Okay. And is that list, did you keep it kind of similar to the structure, say that GLS function in NLME4 returns? There's some attempt at backwards compatibility in that way. So I'm just thinking, I have a wrapper for GLS that would be really nice for me to just add an option to choose mmrm as the engine instead.
We didn't. Yeah, I have to be honest. We didn't try to be close to GLS results object in terms of the, let's say, internal structure of the object. But we really try to have a lot of component getter functions, basically. So when you look at the component documentation, it really allows you to extract a lot of details from the object without, let's say, assuming that the object is stored in a certain way, right? So I think that should get you a lot what you need. If something is missing, let us know, then we can probably add it here. But yeah, a lot of the things you might want to extract from the object probably are, you will get it through this component. And the good thing is if you use this component, you really don't kind of assume anything about internal things which might change, but you really use this interface that we provide. So that's, I think, recommended.
Right. Yeah, thanks. That looks great.
Okay. Any other questions on the demo?
I don't, this is Wendy again. I don't know if this is on the demo necessarily, but, and maybe this doesn't make sense, but have you thought about adding ways to visualize the results? Again, this is kind of out of my area, so maybe it doesn't make any sense to visualize anything, but
Yeah, that's a good question. So far we haven't added any kind of plot method to this package. I think we could maybe consider simple visualizations, and we actually tried. We deliberately kind of try to keep it like very minimal. Well, it's not that minimal, but let's say from the scope relatively small, so that we really just cover the calculations and the interfaces to the other packages. But that said, if you are interested in more high-level plots or tables as well, there is, let's say, an add-on package which is called turn.mmm. So I can also quickly show you the page for that, which is basically building on top of mmrm, but it's much more heavy in terms of dependencies, and so it's using then, for example, ggplot2 for the plotting and so on. So this is kind of the turn.mmm package. So you can also find that easily by Googling turn.mmm. And that really gives you, I mean, you can basically fit these models. It has a little bit more, let's say, restrictions there. But then you also get, for example, tabulation and plots of least square means per visit and treatment arm. You get other kind of diagnostic graphs, plots also of the covariance estimate and so on. So also forest plots, for example, by subgroups. So it gives you much more, but it also kind of, yeah, has a bit more assumptions that might not be suitable maybe for your application. But that's kind of our current kind of add-on package that does, yeah, some plotting and some tabulation. And this, for example, we use then as the interface for clinical reporting purposes. So when we have really clinical studies reading out, then we can use this package to do the, yeah, tabulation and plotting.
That's great, thank you. Which leads me to another question, again, which might be better later, but I'll ask it now. I'm really interested in the software engineering aspect because you know, I've heard of colleagues running into that at you know, the stat agencies where, you know, a statistician develops code and then, you know, has to work with the production folks to stick it in the production pipeline, but, you know, they don't necessarily understand all the, you know, the software engineering aspects. So, so I guess my comment there, maybe you have more of that in the YouTube videos that Ya mentioned. But to get to my question, so is it good software engineering? It doesn't sound like it, practices to depend too much on other packages that could then go away or not be maintained properly? Did you account for that? It sounded like you did in some of what you just discussed, but can you comment more on that?
Yeah, so this is always like a important consideration, like what dependencies you have in your package. There is let's say different perspectives on that, but let's say I think it is agreed upon that, yeah, you shouldn't take as many dependencies as you can, but you should try to minimize them in some way, right? And then the question is, where is a good trade-off, right? So if we look at mmrm package, let's look at quickly at if you browse source code here at the description file. Just to mention maybe why we have certain dependencies and why not, or something like, for example, right? I mean, for example, we have some packages that we import from which are important for the software quality. For example, we have some package that does the assertions of the inputs, so basically input checks for all the functions. We have a package that's more or less just for lifecycle management of the API of the package. Of course we need to use methods for being able to have generic functions and methods. NLME, I think that's just used for a certain optimizer that we use from there. NumDere, for example, that's for numerical Hessian and gradient calculations. So we do have some dependencies here, and in particular, a very important dependency for us is TMB. So that's called Template Model Builder. So that's kind of an R package that wraps like a C++ framework, where we really kind of implement all our kind of log likelihood functions and covariance structures. And that really gives the package kind of the speed that it has, because we use C++, and you see that also here, the linking tool. So these are kind of our C++ dependencies that we have, right? But for example, we try to stay away from too much, maybe too heavy dependencies for this package, right? So try to keep it relatively small here in the dependencies. So I agree, it's always like an important question that needs to be carefully considered. And I think here also there was an important design consideration in the beginning, to say, let's keep this package minimal, not assume too much how you want to do your tabulation or how you want to do your graphs or something, but just do the calculations in a good way. And then you can have add-on packages like turn.mmrm, which are much more heavy, right? I mean, if you look here, for example, at the description, it's much probably, yeah, it has much heavier dependencies here, for example, ggplot2, or R tables, it's also pretty heavy dependency, tidyr. So here you have heavier dependencies, and each of those actually might also have quite a lot of dependencies. Turn also here's a heavy dependency, right? So sometimes also breaking up things maybe into 2 packages might also be helpful.
Yeah, that's a good point. And I forgot about the sort of hierarchical nature of the dependencies like that.
Yes.
It's not just
yes.
the first level, but then, you know, the other ones
Yes.
going down.
Yes.
Great, thanks. Well, I think we have 5 minutes left. Does anybody have questions? I'm sorry, I kind of, oh, you got more slides. Okay,
let me quickly give back to Ya for the closing, okay?
Okay, yeah, thanks, Daniel. Yeah, I'll quickly conclude. So first of all is our long-term perspective on software engineering. So we view software engineering as a critical competence in producing high quality statistical software. And we still have a lot of work to do in terms of establishing, disseminating, and adopting best practices for engineering high quality open source software. So we believe that by improving the way software engineering is done, will eventually help improve the efficiency, reliability, and innovation within the biostatistics community. Yeah, this is our last slide. We will quickly talk about our new packages in development.
Yeah, you don't have to go too quickly. Donna made me co-host, so I can keep going after 4. So if people have questions, I'm not going to cut you off.
Okay. So our working group is also planning for developing new R packages. So there's a package called SAS-R, which is under active development right now. This package aims to run analysis in SAS from an R session. So this is particularly useful when we want to compare SAS and R results during our R package development. And to our best knowledge, there is no R package to do that currently. And we also have 2 other packages at the planning stage, which are the health technology assessment methodology, and another one called the Bayesian inference for mmrms. Yeah, so I think that's all for our presentations, and happy to take any questions you may have.
Great, thank you so much. That was very, very interesting. I'm not in the biopharm area, but I was able to get a lot out of what you were presenting. So thank you. So Donna's not going to totally cut us off, so that's good. If anybody would like to ask a question, then we'll just do it in a informal way. Just go ahead and unmute yourself and ask Ya or Daniel your question. I never know how long to wait to see if somebody's going to. Go ahead, Nancy.
Hi. Yeah, this is Nancy Brecken. I have a question for you all, and that is there are also efforts going on within the Fuse group. There's a Admiral package that they're developing for ATOM data sets. Just wondering if you all have made contact with anybody in that organization, because it seems like a, sort of some mutual benefits there.
Well, Daniel, would you like to take that question?
Okay, I can take that. Yeah, thanks. Yes, so we are very well aware of all other efforts, and actually sometimes we even have personal connections with the people that are in these other working groups. And I think the idea here for this working group, why did we set this up in addition? Like, you could even ask, is there really like a need for another one? The idea was to link it closer to the biostatistics community in particular, right? So a lot of the Fuse work has been traditionally more in the statistical programming community, kind of home-based there. and it hasn't trickled very much into the biostatistics community. So that was one reason why we wanted to really also bring it to the biostats community. That was one reason. And the other reason is that this working group focuses much more on statistical methods implementations. So it's not about standard data formats. It's not about standard data, standard VAD kind of stuff, or reporting pipelines or something like that, right? It's really about, there is this method that's pretty important and we want to implement it in a good way. So that's kind of a little bit more the focus on the, let's say, products of this working group in terms of packages. So those kind of two motivations was kind of the reason why we also thought that so far wasn't represented in those kind of working group landscape, and we wanted to come together. And of course, we're still very heavily connected with all the other groups. And we also, for example, see that, for example, turn.mmrm package, that's part of the pharmaverse. So that's kind of in this end-to-end clinical reporting pipeline, and mmrm package basically supporting that as well. So we see this kind of mutual synergy there, definitely, yes.
Great, thanks. I see, Scott, you unmuted.
Yes, thank you. I had another question. So, and I guess I'll apologize in advance if it's an annoying question, but my understanding of mixed models is that we have fixed models that have only fixed effects. We have random effects models that have only random effects. And we have mixed models that have some combination of fixed and random effects. And what you've implemented here, as at least what you've shown so far, doesn't have any concept of random effects. It has, you're directly modeling the covariance structure. So I'm curious why you called these mixed models.
Okay, yeah, very good question. It's basically a totally wrong name. My apology for that is the name didn't come from us. It was coined in a paper, quite long ago, and it kind of has stuck, in people's heads, this name. So that's why we go with this name, even though it's really just wrong. So you're completely right, and also as we show on the README page already and so on, we try to keep it very prominent. This package actually doesn't do any random effects, so in that sense, it's not really mixed. So it's really fixed effects, it's fixed coefficients, and covariance modeling. So it's basically really just generalized linear, generally squares. Yeah.
Right. Okay. Fair enough. Thanks. I guess for myself, I took up the suggestion from Pinheiro and Bates to call these extended linear models, but not many people seem to do that. You're right. So
yeah, that's probably a better name. Yes.
Yeah.
I see there's a question in the chat. I'm hoping you can discuss the appeal for companies like Roche, et cetera, for producing open source that can be used by competitors. Could you maybe comment on why it is in the interest of companies to make statistical method software public and open source rather than proprietary? That's a good question. I'm an advocate for open source, but interested in hearing from Daniel and Ya.
Maybe I can start, and then Ya can maybe add from her perspective as well. So that's a very good question, and we also discussed this question internally sometimes again. So the reason is really that it's the right thing to do, and we believe that, and we also see that happening. And why is the right thing to do? Because it just doesn't make sense for every company internally to develop, for example, an mmrm package, right? Because ultimately, in the end, this is not the intellectual property that we are selling and that we are kind of benefiting the society with, right? I mean, in the end, we develop medicines or diagnostics, and those hopefully help patients out there, right? this is just a means to an end. It's just a tool in the kind of millions of tools that we need on the way to obtain these medicines or these diagnostics, right? So that's why and of course another dimension of this is, you know, we have to submit this kind of data sets that we generate to get approvals for these medicines and diagnostics to regulatory authorities. And more this kind of data and also analysis will probably be public. Also, and it's good that it's going to be public to the wider, you know, public and wider kind of academic community as well, right? And those people rightfully demand to know how the data is actually analyzed, right? So at that point, we would, I mean, anyway, we would need to publish this kind of software anyway at some point, right? So it just doesn't make sense to keep it kind of internal, to keep it kind of secret. That's one reason. And the other reason is it's also just much more efficient if we can share the burden of developing these packages and maintaining them and improving them across the whole industry, right? So we already see now we have 5 companies already really actively contributing code to this package, which is amazing, right? So we really already save money by doing this all together. Everybody of us saves money by doing this together rather than everybody themselves, right? So for me, yeah, it's the right thing to do. It's important to have this transparency to stakeholders, including regulators, patients, academia, everybody else, and it saves money in the end. So that would be kind of my motivation, and that's all kind of our motivation to why we do this. And maybe, yeah, you want to add something?
Yeah, thanks, Daniel. So yeah, just wanted to echo what Daniel just said. I think it's much more efficient to work collaboratively across companies instead of just doing our own. And I think another point I think might be interesting is that at the end of the day, we just wanted to, if the whole industry get aligned and we have a very comprehensive software developed and used by other companies, I think it also will be much easier to get the green light on the regulatory aspect. Yeah, because so far, I think most of the submissions are still using the proprietary software. So by doing it all together across all companies in the industry, it's easier for us to promote the use of R for future data analysis and submissions to the health authorities. Yeah.
Yeah, thank you. That was a great question and a really good discussion. I never thought about the point, Dan, you made about that the different companies are sort of sharing the workload and contributing to it. So it just, you know, helps everybody and then also saves money. I never thought about it that way.
Yeah, thanks for your comments, y'all. I'm coming from the official statistics kind of world with survey research, and it's kind of, I think, maybe a few years behind in terms of this transition to open source software. So this is really helpful to hear y'all discuss what's going on with that industry. So
Yeah, thanks, Ben. I agree with you. But I think we're starting to try to forge in that direction, which is good. One motivation for, you know, the interagency, our users group and our govies. So, all right. Any more questions? And I have to say that, I mean, you mentioned the Pharmaverse. I have realized more and more that I think, I mean, there's other agencies too, but I think the ones who've been sort of at the forefront of, you know, using open source have been, you know, the FDA in the US and, you know, now the pharma industry, you know, internationally. So I don't know what that means, but I find it pretty interesting, and you know, I'm happy for it because you know, you sort of are leading the way. So You know, I mean, I'm kind of generalizing there. There's certainly agencies in the US that are making strides in this area, but certainly the FDA and pharma have been out in the lead. All right. Well, I guess I don't hear any other questions or nothing in the chat. I wish we were in person so we could, you know, you could hear the applause, but here you go.
That's nice. Thank you.
Well, thank you so much. Yeah, we got applause from Eli. All right, well, thank you, everybody. And next month, our govies, we have Tomas from FDA, strangely enough, speaking. He's going to give us a talk on using R for analyzing unstructured text. So we'll get an introduction to how to do that in R. So keep an eye out. You could email me, wendy.l.martinez@census.gov for information on how to register for the next month's event, or you could just go to the meetup, the RGovies meetup, and look for it there. So thank you again, Ya and Daniel. It was a great talk. I really, really loved it. And thanks. Thanks for joining us from around the world, everybody.
Thanks, Wendy, for organizing.
Thank you.
Thanks, yeah. Thanks, everyone. Bye-bye.
Take
Thanks,
care.
everyone. Bye.
All right, bye.